Hello, welcome to my class on Mesomeric and resonance effect. In this, we will discuss about the organic displacement, electronic displacement reaction steps, effects, like we have discussed earlier, the electromeric effects. In this, we are going to discuss about mesomeric and resonance effects. They need some special conditions. We'll see what are the conditions, right? See, the mesomeric effect takes place in unsaturated, especially in conjugated system via pi bonds. So, the mesomeric effect takes place in unsaturated and especially in conjugated system via pi orbitals. Okay. And in this, we are going to talk about some relations, okay, about the molecules. For example, if you consider a carbonyl group, all of the properties can neither satisfactorily be represented by classical formula 1 here, first we are observing here, nor by the extreme polar structure 2, which is obtained through the transfer of pi electrons to oxygen atom owing to its greater electronegativity. So what is mesomeric effect? Mesomeric effect takes place in unsaturated and especially in conjugated system via pi orbitals. So here in between carbon and oxygen, we are observing a multiple double bond in the first structure, and the extreme polar structure is observed when carbon gets positive charge and oxygen gets negative charge in this one. So that is because of electronegativity of this oxygen. But when you see the third picture, it is quite different. That means that actual structure is third structure. It seems to be somewhat in between the two first one and the second one forms. It's a resonance hybrid of which above two are extreme limits. So the resonance hybrid best be represented by our third structure, in which the pi electrons are drawn in preferentially towards oxygen rather than carbon in that structure. So now, if the carbonyl group is conjugated, the carbonyl group is conjugated, and with the carbon-carbon double bond type of system, the above polarization is transmitted further via the pi electrons. So that we will see in the pictures bottom here. That is CH3 bond CH, double bond CH, single bond CHO is there. So CHO aldehyde is there. And once the shift is observed, this phenomena makes the carbon positive in the carbonyl group, oxygen negative in the first structure. And the other structure, once the electronic transfer is taken place, will be having a carbon positive charge in other carbon and carbon chain, not attached carbon to the oxygen. So that was noticed. That means this type of displacement of electrons may also be caused by presence of an atom having at least one lone pair of electrons in conjugation with the conjugated system. So if you see this NR2 linked with CH double bond CH, single bond CH, double bond CH, CH3, and which is again in turn observed in a different manner. Similarly, if the group Cl is there, chlorine, around the chlorine there are three lone pairs of electrons are there, and that is shifted between the chlorine and carbon attached. So after that, this is also noticed. Likewise, OR is there, oxy, ethoxy group or alkoxy group is there. So over the oxygen of alkoxy groups, we have a pair of two pairs of electrons are there, and that is also making a resonance here. So the mesomeric effect may be defined as permanent effect in which the pi electrons are transferred from a multiple bond to an atom, or from a multiple bond to a single covalent bond, or from an atom with a lone pair or pairs of electrons to the adjacent single covalent bond. So this is the definition of mesomeric effect. So mesomeric effect can be defined in three different kinds of methods. That is, pi electrons are transferred from multiple bond to an atom, and also from a multiple bond to a single covalent bond, or an atom to a lone pair, atom with lone pair of electrons to the adjacent single covalent bond. So these three kinds of chances are there to understand what is this mesomeric effect. In short, the effect is caused by phenomena of resonance or the mesomerism in a molecule is called as the resonance effect. So what is another short way is this effect is caused by the phenomena of resonance or mesomerism in a molecule is called the resonance effect or mesomeric effect. So here we are showing double arrowed marks in the pictures, in the equations, the structures. These are actually happens only when the molecule is even not participating in the chemical reaction also. That means non-reacting molecules also it is possible, because it is a permanent effect. In case the compound in the question is solving is having conjugate system of double bonds, then the mesomeric effect is transmitted through whole of the conjugate system, and thus effect may be better known as conjugative effect. So mesomeric effect or conjugative effect, we can say conjugative effect is the name of this electronic displacement effects. Next, next when you see the conjugative effect extends to the degree of dissociation, degree of delocalization, and hence results in a more stable structure. So what is the actual consequence of conjugate effect? So how it will help the molecule in an organic compound of an organic compound is nothing but it will extend the degree of delocalization, and hence it results in a more stable structure. And we have know that inductive effect is also like a permanent effect, and this is also a permanent effect, mesomeric effect denoted by M. It is of two kinds: positive inductive, positive mesomeric effect, negative mesomeric effect. In this positive mesomeric effect, when the transfer of electron pair is away from the atom. So when the transfer of electron pair away from the atom is there, means that is called as positive mesomeric effect. When it is a transfer of electron pair towards the atom is there, that is called as a negative mesomeric effect. So you can see the two examples here in this positive mesomeric effect were shown with X is a group of atoms which is attached to carbon-carbon double bond, and the pair over the X is transmitted towards the carbon sign unsaturation, where the carbon gets the negative charge after the result. So here another one, negative mesomeric effect you observe, where Y is a group attached to the unsaturated carbons, and this is shown likewise the electron pair from the carbon double bond on the pi orbital shifted towards Y group. So the positive mesomeric effect can be understood in such a way. So to understand that one, what kind of groups which are said to give positive mesomeric effect, nothing but OR, OH, NH2, NR2, SR, like that, which are actually capable of conjugation with the attached unsaturated system. On the other hand, we have negative mesomeric effect is also there. They are shown by CO, NO2, CN, SO3H, etc. It is due to the presence of an electron negative atom like oxygen or nitrogen, which functions as an electron sink in that. Next, if you see another example here, bottom we have carbon-carbon double bonds, and finally NO2 group is attached to that one. You write the resonance of it, then the positive charge will be present on carbon and negative charge of the NO2 oxygen is there. And this effect is actually common occurrence in aromatic compounds also noticed, where the group X with unshared pair of electrons is attached directly to the phenyl group, and thus the lone pair of electrons become conjugated with the benzene nucleus, and the compound exerts positive mesomeric effect. So you'll see the first picture in this benzene ring with X is the group is there, lone pair is there. That is a positive mesomeric effect. From that towards the benzene nucleus, the electron pair will be shifted. That means the electron pair is shifting away from the atom. So that is the positive effect. And towards the atom, if you observe the negative inductive effect, negative mesomeric effect, minus M effect, second picture, second structure. Similarly, groups like NR2 plus NRO, double bond S, etc. They when attached to benzene nucleus, they will definitely exert minus M effect. Since mesomeric effect is a permanent effect, always operates in the non-reacting molecule. It's like inductive effect, affects the physical properties of molecule. Again, like inductive effect, it may be either aid, it will be neither aid or hinder the particular reaction. So like inductive effect, it may either aid or hinder the particular reaction. That means there is no such kind of chemical reaction discussion in this kind of effects. Why? Because internally in the molecule, these inductive effect as well as mesomeric effects it takes place, both comes under permanent electron displacement effects. So this is what we have observed in this video. We have discussed about mesomeric and resonance effect. We have taken the examples and we have told the positive mesomeric effect and negative mesomeric effect, and what kind of groups actually responsible for exhibiting the positive and negative mesomeric effects also we have shown in this video. Hope you have observed the things what we have discussed in this class are nothing but electron displacements continuation of the previous session. The previous session we have discussed about the electromeric effect. In this we have started with the mesomeric and resonance effects, mesomeric resonance effects, and these effects actually led to the stability of the molecules also we have learned. And further detailed discussion about the mesomeric effect is resonance effect is supported by resonance concept in this organic chemistry. So that will be discussed in the next class. Until have a nice day.